This video is on literal equations. Literal equations are rearranging formulas. So literal equations solve a formula or equation for a specific variable. The end result should produce a new equation where the variable of interest is isolated. The reason this is important is because a lot of times when we have to substitute values in for letters, we then have to solve it anyway. So then if we can solve for one letter and then substitute values in, we can put it straight into our calculator or do order of operations much easier, especially when we have fractions and decimals. So what we want to do is we're going to take an equation and we're going to solve it. Now, if we remember, solving equations uses SADMEP. SADMEP. So from a previous video, we follow our little diagram of using SADMEP. We use subtraction and addition first, then we do division and multiplication, then we look at exponents, then we go to the inside of any parentheses we have. So we want to isolate the variable we're looking for by adding and subtracting first, then multiplying and dividing, then worrying about the exponents, then worrying about the inside of any grouping symbol. So our first equation is A equals BH, but we want to solve for H. So what I'm going to do is rewrite this problem so that I can work with it. A equals BH. Then what I'm going to do is, because I want to solve for H, I'm going to circle that H in pink. I don't want to touch it. I want to make sure that I get everything away from that letter H. So I look, there's nothing that I can add and subtract away from H because B is multiplied to it. So if I don't have to do subtraction or addition, I have to go down to division and multiplication. If I am multiplying and I want to solve, I do the inverse of multiplication. I want to divide away from that H. So I want to divide everything by whatever is attached to the H. B is attached to the H, so I divide by B on both sides. When this happens, the B on the right goes away from top and bottom. I will have H completely alone because once those are gone, H is 100% alone. So I can say that H is equal to whatever I have over here is A divided by B. And that is our literal equation. There are no numbers in here, but now if I want to find the height, so area is equal to base times height, that's the area of a rectangle. If I know the area of the rectangle and the base of the rectangle, I can plug those in right away and know what my height is. On the second equation, we have C equals 2 pi r, and we want to solve for r. This is circumference of a circle. So if I know what the circumference is, I have my 2 and pi, I can solve for r. So again, I'm going to rewrite this problem so I can work with it. C equals 2 pi r. I want to solve for r, so I'm going to circle that in pink so that I don't touch it. And I look back at SADMEP. Adding and subtracting. I do not have any addition or subtraction signs in this problem, so there's no adding or subtracting. I look at multiplication and division. The 2 and the pi are actually both multiplied to the radius. This is 2 times pi times r. And don't forget, pi is a number. It is not a letter. So both of these are multiplied by r. So if I want to undo multiplication, I do the inverse by dividing everything by that value. So I want to divide everything by what's attached to the r. The 2 and the pi are both attached to the r. So I divide by 2 pi. So when I divide, 2 goes away with the 2, and pi goes away with the pi. Once I divide that, my circled r will be completely alone. Therefore, I will have my final answer. I'll just rewrite it as r equals, and I have on the right-hand side, c divided by 2 pi. Because there's nothing else I need to do to simplify that. Then I can highlight this as my final answer. On this next one, we have P equals 2L plus 2W, and we want to solve for W. This is the equation to find the perimeter of a rectangle or a quadrilateral. So I'm going to, again, rewrite this problem as P equals 2L plus 2W. I want to circle my W so that I know that that's what I need to get along. Now I go to my SADMEP, so I add and subtract. I have an addition sign, so that means that I have a term that is not multiplied to my W. So if this is where my W is, I have my 2L separated with an addition sign. So my 2L is positive, so it is technically added. Even though there's an addition sign here, that doesn't mean that that is necessarily added. The plus sign on the 2W does not mean that the 2L is also added. The sign on the 2L tells me if it's added or subtracted. Since there is no sign, that is automatically assumed to be a positive value. So yes, 2L is added. So in order to undo addition, I do the inverse, which is subtraction. So yes, I do want to subtract the 2L from both sides. So minus 2L on the right and minus 2L on the left. We will end up having P minus 2L equals 2W. Because 2L minus 2L goes to 0. Now, I do not have my W all the way alone yet, so I'm going to circle that again in pink because I still need to get my W completely alone. Now, it says P minus 2L. I kept the P in front because that was already there, and then I just subtracted it from the P. Be careful because when you subtract, it does matter which part's negative. P was positive, and I did not change that. 2L became minus, and I still have minus 2L. Now that I've added and subtracted away, I need to go to multiply and divide. My 2 is still attached to the W through multiplication, so I need to do the inverse of division. So I need to divide everything by 2, and that means everything. So when I divide by 2, these 2's will go away, and now my W will be completely alone. So I can say that W equals. Now over here, I have P minus 2L, and all of that is over 2. So that's why it's important to know that we're dividing everything. So I'm going to put P minus 2L, all of that over 2. Now, there is another way of looking at this. Because we divided everything by 2, I can see this as W equals. I took P and divided it by 2, which does not simplify. So it would be P divided by 2 minus. I also took 2L and divided it by 2. Well, 2L divided by 2 will become just L. Sometimes it's easier to write it as just all over instead of trying to simplify it out. So I will highlight this answer because we don't have to think about how does that 2 affect both parts, but it can. So if you want to simplify it further, you can always break it up as P over 2 and also 2L over 2. That is why we divide everything by 2. That is the part where many people mess up. This next example is E equals mc squared. You might have heard of that from Einstein. We're going to solve for m. So I'm going to write out E equals mc squared. I want to solve for m, so I'm going to circle m in pink. Now I want to use SADMEP. So nothing is added or subtracted. We have no addition or subtraction signs, so I can skip over adding and subtracting. I have a letter attached to m. My entire c squared, I don't care that it has an exponent, I care that it is attached to the m through multiplication. So I want to get everything away from the m right now by dividing. Because it's multiplication, I want to undo that by division. All of c squared is multiplied to m, so I'm going to divide by c squared on both sides. So when I divide by c squared, on the right-hand side, goes away. M is completely alone now, so I can write out the final answer. M equals. On this side, I keep everything as it is, because it cannot simplify further. So m equals e divided by c squared. I don't have to worry about the exponent because I was not trying to get c alone. This is our final answer.